Hello, everyone. My name is Shuja Mandal, and I'm an 11th grader from Amador Valley High School in Pleasanton, California. And my project name is GeminiCare, which I submitted to the Gemini API Developer Competition. And an overview of this is it's a Gemini-powered app that assists medical professionals in diagnosing and monitoring autistic patients. Now, the problem statement is that clinical and scientific data shows a higher risk of adverse events and trauma in people with an autism spectrum disorder, or ASD for short. And there's a significant challenge in the timely treatment of ASD in a non-invasive manner, as 1 in 36 kids have been identified with autism, and there's severe issues associated with this, like chronic mental health, suicide risk, and harm to others. Thus, the primary goal of my app is to develop a multi-model autism monitoring and analysis system, which leverages the Gemini Gen AI API to assist medical professionals by providing efficient methods of diagnosing and monitoring these patients. And the application will analyze different multimodal data inputs like video recording, speech patterns, and textual information from patient interactions to detect and predict symptom patterns as well as severity. And this aids medical professionals to make informed treatment decisions. And here are the users, for instance, a clinician, patient, and researcher, and their use cases where the patient receives improved diagnosis, the researcher secures deeper insights, and the clinician achieves precise diagnostics and personalized monitoring. Now, the use case or the app walkthrough is something I'll demonstrate in the later slides. And going into the deployment diagram, here we see a user, and the Streamlight app is running at this link and is hosted on the virtual machine in Google. And it uses the Gen AI API, which is powered by Gemini, as well as it uses text, audio, and video, which is stored in the Google Cloud services. And the lab users, patients, audit logs, and analytics are all stored in the database. And this whole thing is hosted in Google Cloud. So I'll head over here. As we see here, this is my VM instance for GeminiCare. And here I'm storing the data for the patient sample video, audio, and text. Now, all my code is publicly hosted on GitHub here, and there are extensive documentation for the development guide as well as user guide for GeminiCare. And we'll see here in my code where I initialize the GeminiCare model or the generative AI model using Gemini. And here I'm able to, this is my analyze text function where I can analyze the sentiment from the text that I'll upload in the future in the app demo. And here I'm able to prompt the model and generate responses, including performing sentiment analysis and finding different tones. Now onto the live demo. Here, as let's say I log in as a clinician, I'm greeted with the home page as seen here, and I can select an existing patient, for instance, Ender, and I can see their medical history, doctor notes, and what GeminiCare analyzes, which is the speech sentiment trends as seen here. And there's other information as well. Now there's a tab for patient registration where I can upload patient information and save this, which will be uploaded to the database. Now in the patient diagnostic tab, which is the most important feature, I'm able to, for instance, let's say I took an interview of an autistic patient, I would upload the speech text as seen here, and I'm able to analyze the user interview in real time. And as we see here, it's currently running and loading the Gemini model by calling the API key, and it's able to generate text as where the text file has been uploaded, and perfectly here we generate text of what it's saying, as well as the sentiment analysis and what the text expresses. And it also generates a useful tone analysis with a score as well as an explanation. And it also extracts keywords like the intent keyword and its explanation. And it's accompanied by visual insights as seen here with the trends and a patient summary. Now, another input type is audio, where I can submit an audio file, for instance, and here's a really brief clip of what it might sound like. And once I upload it and I click submit, and I'm able to analyze the speech, in real time it's reading, and it perfectly generates this text. And here it demonstrates how there's a quota exceeded because my Google Gemini is running in real time. But we're able to generate the speech sentiment, which is neutral because the text expresses desires and demands. And if I scroll down, the resource exhausted quota will continue to will expire in a minute. Now, the final audio type, which I'm able to analyze is video. So let's say I upload this video of the patient sample, and I click Analyze User Expression. Here, the Gemini model gets it perfectly, where it says that the text went away, but when I click Analyze User Expression again, it said that the user had his jaw clenched and the person is in a grimace and he's very angry and he's frowning, which is perfectly correct as seen here. And here's an emotional distribution as well. And of course, it generates a patient summary as seen here. Now, The impact of this app is significant because there can be improved health outcomes as with more accurate diagnostics and personalized treatment plans, it can improve the quality of life of patients. Also, GeminiCare uses the AI to analyze complex multimodal data, and this minimizes the subjective bias that may be inherent in traditional psychiatric evaluations. And I see a strong impact and social cause that GeminiCare has in the future. Now, onto my future work, I hope to implement this in real healthcare settings, and there's many functionalities that I can implement, including the need to provide secure authentication and deploy this app in a scalable service. But overall, GeminiCare can leave a huge social impact. And I want to thank Google for presenting this opportunity. Thank you for listening.